सबैजनालाई स्वागत छ। आज पनि हामी बिसिए सेकेन्ड सेमिस्टरको हामी सबै कुराहरू पढ्नेछौँ। हिजो मैले 40 पन्नासम्म पढेको थिएँ। आज म 40 देखि यता पढ्नेछु। डेटा स्ट्रक्चर एन्ड अल्गोरिदम डिएसए 40 पन्नादेखि यता करिब 20 देखि 30 मिनटको पढाइ हुन्छ जस्तो लाग्यो मलाई। हिजो 40 पन्नासम्म थियो र 41 पन्नामा मैले मेरो स्कोर लोड गरिसकेको छु। हाउ क्यान वी सल्भ द limitation of linear queue using the circular queue explain भनेको छ। सुरुमा इन फ्रन्ट रे अनि रियर प्लस 1 गर्ने रे अनि म्याक्स साइज 1 इजिकल टु बी 3 1 इजिकल टु 0 फल्स इल्स टेक भ्यालु एज 10 इल फ्रन्ट -1 इल्स रियर प्लस 1 म्याक्स साइज 3 divided by 3 q rear data is inserted. In this way, the circular queue overclass the limitation linear queue by inserting the new element in a circular queue by increasing the rear भनेको छ। अनि हाम्रो छ च्याप्टर 4 linked list a linear collection of the specially designed data structure called the node and the linked and another node by devising start node linked address data insertion operation to insert the node in the list, allocate the required memory to the node, assign the data in a detailed field, adjust the pointer to the link to insert the node at the required place. There are three types of insertion of the node in the linked list: insertion at the beginning of the list, insertion at the end of the list, inserted at the specific position of the list. Algorithm for the insertion of the new node at the beginning of the list. Start allocate the memory for a new node, assign the value in the data field. If the linked list is currently empty, भर्खरको linked list चाहिँ empty छ भने currently empty, then the new pointer is found. Set the external pointer to the point to the new node and start 16345 null address field link list link pointer next field program password input data to be insert create a new node data if the insert data is null and then the new node next null the next new node next start new range exit algorithm to insert a new node at the end of the linked list, start allocate the memory for a new node, assign the value in the data field, assign the null to the linked field and the new node by default. If the list is empty, then the external pointer of the point and otherwise the transfer the unit in Java. Last node is reached and then insert the new node after the last node by assigning the link field in the last node to point the new node start a b c d null program while p next null p is equal to next p next new node null p next line chain with string and alternatively step 1 input the data to be inserted create a new data new node data step 4 new node step is next is equal to null step 5 start is equal to null while start is equal to new node. Step 6 step temporary start step 7 report the step until the new node temporary step go temporary temp next is set temp next new node in the temp is temporary pointer to all the node address start a temporary the insert the node into the specific position of a singly linked list and position algorithm. Step 1 start step 2 allocate the memory of the new node. Step 3 assign the data transfer the list of the data in the given node. Assign the linked field of the new node to the point the link of the following node. Assign the link field to the given node and the new node stop. Assign a stop deletion operation. It is possible to delete an item from the existing list of the three-way deletion from the front beginning, deletion from the deletion from the specific position list algorithm to delete the an element from the front or the beginning of the list, delete the data, start if the list is empty, print else, move, start the pointer and the second node, the delete the first node, stop We start A, B, C, D algorithm to delete an element at the end of the list. If the list is empty, print is list underline, transfer till the node. Next node is null and remove the previous node and set a node null. Last node is deleted. Step 1 algorithm to delete and insert element from the specific position of the singly linked list start hold the address for the first node set a node start if the node and the node set I is equal to 1 if L is start if the list is empty ptr is equal to node print underflow and the system initialize the counter and the pointer set I0 set ptr start repeat step 2 until set temporary ptr set ptr in the next set I plus 1 print deleted element free ptr stuff types of linked list is singly list, doubly linked list, circular linked list, singly circular linked list, doubly circular linked list, double linked list. The two address field are present in a node and one of the link is store address in the following node while the next address field is store the address of the previous node, the next link of the last node and previous link and the first node is null previous data the next node address following the node representation of the doubly linked list is structural node struct node next previous ahead nil data structure real-time application of the doubly linked list. A doubly linked list is the used as the web page of navigating the both forward and backward direction in the browser. It can be used with all of the transferring the both forward and the backward direction. Deletion of the node can done easily. Reversion of the linked list is easy. Insertion can be performed efficiently at any node. Disadvantage implementation of the linked list, static implementation, array dynamic implementation, implementation of stack using the linked list, implementation of the queue using the linked list, implementation of stack using the linked list to operation that we apply on the stack are push and pop. The push operation is similar to adding a new node at the beginning of the linked list. The stack items can be accessed only through the top and the linked item can be accessed from the pointer to the first node of the list. Similarly, removing the first node of the linked list is similar to type of popping on the item from the list. In the sixth case, the only immediately accessible item of a collection is removed from their collection. In the next item, it becomes immediately accessible to one. The first node of the linked list is the top of the stack. Start A 15, 16, 17. Push pop insert at the top 5, 15, 16, 17. Circle on the top start 15, 16, 17. Right algorithm to implement the stack using the linked list algorithm to insert a node at the beginning of the linked list and removing the node from the beginning of the linked list implementation of the queue using a linked list dynamic implementation of the queue. To implement the queue in the linked list, we make a final first node and the linked list as a front, the last node as a rear. So we need to use the pointer validator from front and rear. Initially, when the queue is empty, both front and rear will be null. The in queue and the new queue item will insert after the rear node and update the rear point and the DQ front rear Instagram front start a 20 null 20 30 null application of the linked list implementation of the stack in the queue arithmetic operation in non the long integer implementation of the graph dynamic memory allocation representation of the polynomial memory management advantage of the singly listed dynamic memory allocation. A dynamic size is to insert a new node at a one time or any time deletion of existing node is easy, faster accessing to the element. A disadvantage of the singly listed memory is wasted because of the pointer require more memory or stable. Random access is not allowed. We have to access a element sequentially from the first node, reverse transferring in a different to perform list of as an edited a linked list is the change of the node and the other way the node is linked consists of the two field in the data and the next field data field is stored the actual element on the list whereas the next address is start for field is star address in the next need inserted element at any position of the list. Get a return an element on the list from its a given position. Replace a given element at any position and another element. The element return true is a list and empty. Empty is false. Return true list and HTTP chapter of 5. Root level is initial node level 2. Root degree of tree. A tree is a hierarchical structure in which the hierarchical relationship exists among the several data item. A tree consists of the node with a parent children relationship. It is a non-linear data structure. Basic advantage of the tree root. It is the first node in a hierarchical data among element in the class item. Each item is in the tree is called the node. The node that produces another node is cloned and the parent node from the above figure. A is the parent node and the B and the C and the night. I thought about it. A binary tree is a tree in which no, they have more than the two children. Typically, these children are described as the left child and the right child as the parent node, left, right level two, right level three. Binary tree, basic operation in a binary tree. Create a empty binary tree, transferring a binary tree, inserting a binary tree, deleting a new node, searching for the node, determine the total number of the node, determining the total number of the node, for determining the total number of the node leaf 5, node 5, find the smallest and the largest element in the node, find the height of the tree, height 3, height 2, height 4, 1, height 4, 8, 0, property of the binary tree, the order binary tree is 2. Binary tree does not allow the duplicate value. The maximum number of the node in the level 1 binary tree is 2 plus 1. The maximum number of the node in a binary tree of height. The binary tree with a T list has at least a log 2, log 1 level type of the binary tree, strictly binary tree, core binary tree, full binary tree. The tree is used to be a binary tree if eventually the non-leaf binary tree has an empty left or the right subtree. In the other one, it can have either no children or the two children. Each node contain either or node 2 degree complete binary tree. All the node are completely filled and except the last level. In the last level, all the node can be left as possible. In a completely binary tree, the node should be added as a UFT perfect binary tree or the R tree is the perfect binary tree in all the interval have the two children and all the leaves node are arranged in the same level. Node all the perfect binary tree are the full and the complete binary tree but not the vice versa root. Level 0 internal node, level 1, level 2 left node, degenerate binary tree, all the internal node have only one child, no left child, needed the balanced binary tree. The difference between the height of the left subtree and the height of the right subtree for every node is not more than 1. It is also called the balanced binary tree, ABN tree, red black tree, level 0, level 1, level 2, height of the left subtree 2, height of the right subtree 1, difference 2 minus 1, tree transfer in the binary tree. It is the way in which each node in a tree is visited exactly once in a systematic manner. There are the types of the waves in the transfer binary tree. Predator root, left, right, visit the node at the left subtree, visit the node at the right subtree. Predator tab, predator A, B, C, D, E, predator, in order A plus B, in order B, G, A, B, H, C, I, C, F in order as D E A I F J C K post order left right road post order A plus B root post order G B B H I E F C A visit once period order visit twice in order visit thrice the S order with the shortcut period order A B C D H C I G E F G in order H D B E I E A F C A post order H D I E B F G C A construct the binary tree of the following condition in order A B C D C E B A C D E step 1 B B A step 3 B A C D step 4 B A C D E in order post order so shortcut we use and add and pre order In order, post order in order as B D I E A F J K E G H, post order as D I E B J K A, root order. Construct an expression tree of an given instruction expression A into B minus C in equality. PQ, we take an operator with the lowest precedence as the order node. A B into C, B into C. Binary search tree, it is the binary tree which either by infinity or the satisfaction of the following condition. Every node has the value and no two has and no two node have the same value. All the value are unique. If there exists the left child or the left subtree, then its value is less than the value of the root node. The value of the right node or the right subtree is larger than the value of the root. 50, 30, 75 operation in the binary subtree. Insert and deletion, transferring period order, post order. In order algorithm to be inserted on a node BST, start, insert data, loot data, if data, root info, proceed in the left, right of the tree. If the data root right info proceed into the right side of the tree, compare the data with the row right node and information of the tree. Repeat the step 2 and 5 until we meet the empty subtree where we can insert the data stuff. Insert 55 on the following tree. Consult the BST and the following element. Insert in element 39, 45, 30, 60, 42, 35, 32, and 44. Also perform the transfer period of 39, 30, 25, 45, 42, 44, 60. In order 25, 30, 32, 35, 42, 44, 80, post range 25, 32, 33, 44, 42. Construct the BST using the following data UNIEB EST thunder of geometry. Construct the BST, construct the 30, 22, 15, and 10, 35, 40, 49, 95, 8, suburban STR, order SBAR and TUII in order ABINR shift post order AINRUS. AB algorithm to delete a node from the binary search tree and first search and locate the node and the to be deleted and only the following condition the node to be deleted and as no condition simply the delete node remove either the if the node to be deleted and as exactly one child copy the child to the node and delete the child. If it has the left child find the largest element from the corresponding left subtree then replace the largest node information with the deleted node if the right children from the smallest from the corresponding right subtree, then the reposite smallest node information within the deleted node. If the node to be deleted as a two children following at the same process as given above, and select a child and find the small or the large node and replace with the delete one node. This node is get user after deleting the node should be always in the binary search tree. No child delete 9 password root 9 replace child delete two child left subtree right subtree. I just volume lowest value find the lowest value in the right subtree delete the node at the lowest value in the right subtree delete the lowest. Also we can use another technique find the greatest volume right subtree implement delete the node at the send the greatest value in the deleted node delete the greatest node level height depth of the d depth of the I depth of the tree depth of a height of e height of f height of 2 height of a 4 level for balanced binary tree. Balance ABL tree, the GM Edison Beskey of the EM and mathematics developed algorithm in 1952. The tree was called the ABL tree. It is the balanced binary tree in which the left and the right subtree of any node and may differ in the almost one and which is the 60 subtree height. It's called the balance factor. Balance factor height lies right subtree height subtree. In order to balance ABL tree, we use the rotation ABL for following rotation, left rotation, right rotation, left rotation, left rotation, right rotation, no, flat right rotation, now left rotation, right bottom. Algorithm to insert a node in the ABL tree. Start inside the node in the same way as the binary tree trace the path from the new node backward to the road. Consider the node with its imbalance to node if the B node lies on the line apply on the single node and correct the imbalance if the tree node stop construct the ABL tree. Okay, this much for today. फेरि हामी अर्को भिडियोमा भेटौँ। हुन्छ, हस्, धन्यवाद।